Corporate finance practice problem using OneNote. Calculate the bond value for a bond that has semi-annual payments and calculate that when there's a rate change, a market rate change, or change in market yield. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side down in the practice problems area and then down in the 1032 bond value semi-annual rate change tab. Also note that when using OneNote, you might want to look at the immersive reader. Many of our presentations will be mirrored down here in the text area with the same number and name. This area having the transcripts that can be translated into multiple different languages and either listened to or read in those other languages, thereby being a good complement to the presentations up top. Closing this back out, we're going to have our information up top, and then we'll go through those calculations on down below, calculating the value of the bond, but we'll do so in two different times with a rate change that will take place, number one, and number two, we have once again that semi-annual component, which makes it a little bit more complex than if we're talking about the annual payments for the bonds. Also note that the first calculation that we will have, we're going to say that the bonds have been created and issued at that point in time. When the bonds are originally issued, it's much more likely that the rate on the bond will actually match the rate on the market. When that happens, we would expect then the bond to be issued at the face value or the par price, which it will be, but it can still seem a little bit confusing to do these calculations for the valuation of the annuity of the payments and the present value of 1 to determine that we will indeed get back to that 1,000. So we'll start there doing that calculation. Then we're going to make a rate change, having the market rate go down to 8% after 5 years have passed. 5 years then pass. Market rate then goes down to the 8%, the market rate now being less than the rate on the bond, which you would expect at that point in time then to have the value of the bond at a premium, meaning if we wanted to sell it at that point in time, we would probably want to sell it at a premium, something higher than the 1,000, not because 5 years had passed, but because in that time period after 5 years had passed, the market was only giving similar bonds at the 8%, and the bond that we're talking about has 15%, thereby being a good bond in that case, and therefore we would want to sell it at something higher than the face amount. Okay, so first we'll do the present value of it as using the 15 and the 15, the rate on the bond being the same as the market rate, semi-annual payments here. So what's on the bond? We have the face value 1,000. Life, we're saying this is in years 22, and the rate's going to be 15% semi-annual. The market rate, because this is going to be the same point at the point in time that we issue, we're going to say is also then the 15%. So in that situation, we got to be careful about the number of years and the periods being the years times 2 or 44 periods. The rate is going to be that rate divided by 2 when we figure out the annuity payments, as well as the market rate divided by 2 when we're thinking about that 6-month time period. Let's first plug it into the annuity. We got to do the present value of the annuity and then present value of 1 for the face amount that would be at the maturity of the bond. So for the annuity, we would have P times 1 minus 1 plus R to the negative N over R. P would then be the 1,000 times the 15% rate on the bond divided by 2 because semi-annual. Then 1 minus 1 plus R. R would then be the market rate, 15% divided by 2 because semi-annual, to the negative N, which would be 22 times 2 because semi-annual, divided by R, once again, market rate, divided by 2 because semi-annual. Let's plug this into our table type of format and look it on over. We've got the payment, which is going to be the 1,000. I would calculate it this way, 1,000 times the rate that would be on the bond, which would be 0.15. That's going to give us the 150. That would be for a year, however, divided by 2 because semi-annual, 75 for the 6-month time period. You can also calculate that at the 0.15 divided by 2, which would give us the rate per period, 6-month period, times the 1,000. That would also give you the 75 on the starting point. That would be P. Numerator, 1. And then we have minus the 1 plus R to the negative N. So 1 R then is going to be the 15%. Now the market rate, also 15% because they're both the same, divided by 2 would give us 7.5%. 100% plus 7.5% would give us the 107.5% to the number of periods in here, negative number of periods, which would be 22 if yearly, but semi-annual, therefore 22 times 2 or 44. 107.5% to the power of negative 44 is 0.041 about. Let's calculate that for the first time here, just so we can practice that to the power of negative 44. I'm going to convert my calculator to a scientific calculator by going to the Hamburger Scientific Calculator. 1 scientific 1 plus 0.075 is going to be the 1.075 or the 107.5%. We're then going to take that amount to the power of, which is x to the y, and then 44, but we got to make it negative. So it's caret 44 negative 44 and enter. That gives us the 0.04149804 about. You can see it's rounded, of course. Let's go back to the standard calculator now, because I don't like to be scientific all the time. Standard calculator has been returned. We're going to take this 1 minus the 0.04149804 is going to then be that 0.958501 and so on. That's the num, or the numerator. The denom, or denominator, is the market rate, 15% divided by 2, or 7.5 again. So I'm going to take that divided by the 0.075. That's going to give us about the 12.7800 and so on. Taking that number then and multiplying it times the 75 times 75 gives us the 958. That's the present value of the annuity. We also need the present value of the 1,000, but before we do that, let's break the annuity down into a series of present value of ones and calculate it a couple different ways. Any annuity can be broken down into present value of one or these annuities, the present value annuities. However, there's a lot of payments because now we're talking not 22 periods of 1 year, but twice that many, 44 periods of 6 months. So we can do the same calculation, still easy to do if you have Excel. So we'll assume we have Excel calculating this out. 1 period out, we're talking 75 at the annuity payment, which is once again the 1,000 times 0.15 divided by 2. Let's do that again. The annuity payment is 1,000 times 0.15 and then divided by 2. Right, 75. 75, if we present value that, then, and I won't do the present value here, but you can imagine this being done in Excel. We'll then calculate the present value of 1 using a present value formula shortly. But we would get the $70. If we did that for the second period out, same 75 because it is an annuity. Present value in it 2 periods back would give us 65. 65 plus the 70 is the 135. We take the third payment of 75 and present value it 3 periods back, we get the 60. 60 plus 135 is the 195, and so on and so forth, all the way down till we get down to the 44 periods, because these are 6-month periods, not yearly periods, and that would give us the 959. So there's the 959. Now we could add on and tack on one more item at the 44 for 44 periods out, which would be the present value of 1. The face amount that would be paid at the maturity, bringing that all the way back, would be $41 plus the $959 would give us the answer, which would be the 1,000. These two 1,000 aren't coming from the same area here, right? This is the 1,000 that we're present valuing, which is 41, which added to the annuity gets us to the 1,000, which is what we expected given the fact that the rate on the bond equals 15%, the rate on the market 15%. So it's not as intuitive when you think about the calculations that will be the case, but that's what we expect to be happening if we got this correct due to these two rates being the same. Let's then calculate this 959. Actually, yeah, let's calculate this 959 one more time with Excel, making sure that we pick up the proper periods, which can be a little bit confusing if you were to do this in Excel. It would be the present value rate, would be the market rate, which would be the 15%, then divided by 2, which would give us that 7.5. And then the number of periods here would be the 22 times 2, which I would put this in here referencing the cell, times 2. And then we have comma the payment. The payment would be the 1,000 times 15% divided by 2, which we can put all into the formula. That would be the 1,000, 15% divided by 2. If done properly, we would once again get to the annuity portion at that 958.50. Now, I'm not going to go to the tables this time. You could do this with the tables as well, but remember, the tables become less applicable. That's why book problems have more difficulty with these kind of calculations if they want to force you to use a table, because when you're talking semi-annual payments, the life gets much longer and you're talking about rates that could get much lower and whatnot. So that could be adding to complications. You could also have uneven rates and stuff. So we're not going to do the tables this time. And so we're going to go down, but just remember, if you did do the tables, that you'd have to pick up the proper rate and the proper period, so that the rate would not be in years, 15%, it would be the 7.5, which wouldn't be on the table, which would be the problem. And then the 22 would not be the periods, but 6-month periods, which would be the 44. So you'd be looking, in this case, 7.5, which wouldn't be on a table because it has a 0.5, which is the difficulties or the limitations of the table. And then the 44 time periods, making sure you're lining up the percentage to the period that is involved. So now we're going to do the present value of the 1,000, which is going to be present value equals future value over 1 plus r to the n, future value 1,000. 1 plus r is now going to be the 15% market rate divided by 2, 7.5 to the number of periods, which would be 22, but now semi-annual, therefore 44. Putting that into our table, we've got the 1,000 in the outer column, the numerator, the denominator then being 1 plus r to the n, which we're pulling to the inside, 1 plus r then being the 15% market rate divided by 2, giving us the 7.5, 100%, or 1 plus 7.5% would give us the 107.5%, taking that to the number of periods, which would be 22 if annual payments, but 44 because semi-annual, 6-month periods. So the 107.5 to the power of 44, which you may need that scientific calculator again for, gives us the 24.0975243. If we take the num, the 1,000 divided by the denom, 24.0975243, we get the 41.5 again. If we add that then to what we got on the annuity calculation, the 958.5, adding those up, we get back to that $1,000, that $1,000 being the price matching the face value due to the fact that the amount on the bond, 15%, is the same as the market rate. Now let's do that one more time here. We'll do that with the tables now, with Excel, the magic way. So now we're going to say the present value is the rate. The rate's going to be that 15% divided by 2, 7.5%. Number of periods would then be the 22 times 2, or the 44 times 2, comma, because it's not an annuity. And then the future value would be that 1,000. That then giving us that 41.5 again. So now let's switch it up here. Let's do the same thing, but now we're saying it's just like the movie had happened here when they do the fade away and they're like 5 years have passed. The bond is still intact and has been paying its interest. But now the market rate at this point in time in the future has changed to 8% as opposed to what it was 15% before. So now what would be the value of the bond? So now the market rate is less than the rate on the bond. So therefore, if we wanted to sell it, we could sell it at a premium at this point in time because the rate on the bond is paying more than the current market rate. That's not because 5 years had passed necessarily. It's not because we're closer to maturity, but it's because at that point in time, which happens to be closer to maturity, the market rate is less than the rate on the bond. So let's calculate that out. We're going to have P times 1 minus 1 plus R to the negative N over R, valuing this bond again. P is going to be the same. It's going to be the 1,000 times the 15% divided by 2 times 1 minus 1 plus R to the negative N. R is going to be now 8% market rate divided by 2, or 4% to the power of negative N, which is now the 17 periods because it was 22 minus 5 years had passed. So now we're at 17. Then you have to multiply that times 2 because we're talking semi-annual divided by R, which once again is the 8% market rate, but divided by 2, or 4%. Let's plug this into the table. 75, which is the 1,000 times the 15% divided by 2. Same thing we had last time on that one. 1 plus R to the negative N. So we've got 1 plus R, which is going to be now the 4%. Market rate divided by 2, 4%. 1 plus 4% is 104% to the number of periods, the negative N, which is now 17 years. 17 times 2 gives us the 34. So 104 8% to the negative 34 periods gives us 0.263552090. And then 1 minus 0.263552090 gives us 0.73644791. That's the numerator. The denominator then R, market rate divided by 2, 4%. So that divides out to 18.411197776. And then we take the 75 times that number, and we get the 1380.84. That's the present value of the annuity. We then need the present value of the 1000 maturity. But before we do that, let's calculate the annuity a couple different ways, as has been our practice, breaking the annuity down into multiple present value of 1 calculations first. We've got the 1 payment number 1 for 6-month period, $75, same calculation there, but the present value slightly different now due to market rate now at the 8%, or the market rate per period being the 4%, 72. If we pull back the second payment, 75 payment after 2 periods, 2 6-month periods here, pulling that back 2 periods, we get the 69. The 69 plus the 72 is the 141. Third period, $75. Pulling that back 3 periods, 67 plus the 141 gives us the 208, and so on and so forth, all the way down for all these 6-month periods, not years, 6-month periods. We get to that 1381 again, rounded, no pennies, no decimals added this time. If we did that one more 34 period out and added the $1,000 payment and present value of 1 we get the 264, which is greater than what we had before due to us being closer to the maturity for the most part, because 5 years had passed. And if we add that to 26, and we also have a difference in the rate, so those two things are an impact, but it being closer to the maturity would generally mean that the value of the face amount will be going up. As you go closer, the value of the annuity will go down because you'll have less annuity payments. That plus the 1381 will give us the 1644 without the cents or pennies, and that then would be the answer. That would be what we would think our value would be at this point in time. Note it's higher than the 1,000 down here, which would be the face amount due to the fact that we're going to issue it at a premium because the 8% market rate is lower than the rate that's on the bond, which is the 15%. But we did this kind of magically here in Excel, so now we got to calculate this again. Let's first get to this 1381 again by using Excel, doing this the Excel way, which would be the present value, and the rate would be now the 8% divided by 2. So this would be the 8% divided by 2, comma. Number of periods would then be 17 up here times 2, 17 times 2, then the comma. And the payment would then be the 1,000 times the 15% divided by 2. That would be this 1,000, 15%, then divided by 2. That then giving us the 1380.84 again. We're not going to do the tables because we discussed that in the last one. Not doing them this time. Then we have the present value of 1, so bringing back the 1,000 back to its current condition, current point. Present value equals the future value. I'm going to say over 1 plus R to the n, future value being the 1,000. 1 plus R, R being the 8% divided by 2 or 4% to the number of periods, which would be the 17, but that's in years. So we have to multiply it times 2 because semi-annual. Putting that into our table down below, we got the future value of the 1,000. We've got the 1 plus R to the n, 1, R, 4%, which is the annual 8% divided by 2. 1 plus 4% is 104%. 104% to the number of periods, or n, would be the 17 if in years, but times 2 because semi-annual gives the 34. 104% to the power of 34 is 3.7943163. And if we take the num, 1,000, divided by the denom, 3.97943,163, we get the 263.55. That's the present value of that 1,000 amount at maturity. If we add to that the annuity of the 1380.84, we then get the value of the bond, the price, in other words, of the 1644.39. That higher than the face amount on the bond due to the fact that we're going to issue it at a premium or have to pay for a premium depending on what side of the transaction you are on, because the market rate is currently less than the rate on the bond, allowing the seller of the bond to issue it at a higher price than the face amount of the bond. Let's do that calculation. This one, that 263, again, using Excel the easy way, the magic way. We got the present value is going to be the rate, 8% divided by 2, 8 divided by 2. We then have the number of periods, which would be the 17 times 2. This would be the 17 times 2, comma, comma. Look in future value now, that being the 1,000. Bringing that back, there it is again, 263.55.